Hello and welcome to lesson 4.4a homework video. The first problem is a problem where they want you to factor the expression. So the first thing that we're going to do is we're going to determine first, how is the order? Is the order okay or not? So in terms of the order, we're fine because it goes from the squared term just to the first degree term to the constant. So we're good for the order. Now for the greatest common factor, is there anything that goes into any of these? Sorry, let me rephrase that. Is there any common factor between all three of these terms? Is there something, are all these three terms divisible by something? By that same thing? So the answer is no. So we're good there. So the order is good. There's no greatest common factor. So next thing what we want to do is we want to figure out if it's a special case factoring, meaning is it a difference of squares? Well, no, because the difference of squares looks like this, right? And this is three terms. Is it a perfect square trinomial? No, because the ends are not perfect squares. This is a perfect square, but 14 is not. So it's just a regular run-of-the-mill trinomial. It's an easy trinomial, and we know that because the lead coefficient is 1 here. So what we're going to do is we're going to factor this the easy way. Write down your two sets of parentheses. The x squared is a result of the first in FOIL. So x times x would give you that first term. X times x is x squared. The next thing we want to do is we want to read the signs. The signs tell us that we're going to have different signs, meaning one of these is going to be positive, the other one's going to be negative, and the larger of these two numbers is going to be negative. So the larger number is negative. So what we're going to do is we're going to put the negative here and the positive here. And we're going to make sure that the larger of these two numbers is going to be here. So we need two numbers, so let's look at the multiples of 14. So 1 times 14, 2 times 7. Remember, the larger number is going to be negative. Now, which one of these is the right combination that would give us a negative 5x? It would be this one right over here. So it's plus 2 and the minus 7. So this is our factored answer. And we're done. Number 2, how is the order? The order is good. It's the x squared, then the x, then the constant. Is there a greatest common factor? No, there's no greatest common factor between all these three. We see here that we have a 2 as the lead coefficient. That means it's a hard trinomial. That means we can use the box method to do this problem. So draw your box here. What we're going to do is we're going to take the first term and drop it in here. The constant goes in here. Then we're going to multiply the a term and the c term. So 2 times 24 is 48. So now we're going to list all of the possible combinations for 48. So we have 1 in 48, 2 in 24, 3 in 16, 4 in 12, and 6 in 8. Now the middle terms are made up of x's, so we can go through and put x's everywhere here. Now let's read the signs. This sign tells us they're going to be the same. So they're all going to be the same sign. What sign are they going to be? This says they're going to be negative. So they're all going to be negative. Now the question is, which of these has a combination that adds up to negative 19x? It's going to be this one right here. So let's drop those in, negative 3x and negative 16x. Now the rule that we had was that the answer spots are going to take the sign of the box closest to it. So this negative makes that negative. That's positive, so that's positive. Positive gives that to be positive, and that's negative, so that negative goes there. Now we factor out horizontally. The greatest common factor here is going to be 8. The greatest common factor here is x. Here is going to be 2x. And here is going to be 3. So it's going to be 2x minus 3 times x minus 8. And that's our answer. And what we can do is, if you want to, you can go through and FOIL this out, actually multiply all that out, and see if you get this trinomial out of it. And you will if you try it. Alright, number 3. Is it in order? Yes, it's in order. Get the x squared, then the x, then the number. Is there a greatest common factor? Yes, 2 goes into every one of these. So what we're going to do is we're going to factor out the greatest common factor as our first step. Now when you factor out the 2, you're basically taking all of these individual terms and dividing them by 2 to get whatever is left over in here. At this point, we can factor this trinomial. This is a hard trinomial. So we're going to do the box. We're going to drop the first term here and the last term here. First and last terms you drop in here. Now we're going to find our AC. So our A is 2, our C is 5. 2 times 5 is 10. So let's list all of the combinations for 10. There's only 2 of them. The middle term is made up of x's, so let's make these x's. Now let's read the signs. This tells me they're going to be the same sign. This tells me they're going to be negative. So all of these are negative. Which one of these adds up to negative 11x? Be this one right over here. So what I'm going to do is I'm going to drop these in. Doesn't matter the order for these. Now I'm going to allow these 3 boxes to give their signs to the answer. So negative, negative, positive, 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 negative, negative. Now what we're going to do is we're going to factor out the greatest common factor here. So between 5 and 10x is a 5. 1x and 2x squared, x. Over here, 2x. Over here, 1. So don't forget this, because we already factored a 2 out. So that's part of the final factor. So x minus 5 times 2x minus 1. And that's your answer. Number 4. Let's see if the order is okay. The order is perfectly fine. Is there a greatest common factor? No. Now let's go back to one of our first things that we checked. is it a special trinomial, or is it a special binomial? It's not a binomial, so we're not going to look for difference of squares. But we could look to see if this is a perfect square trinomial. And let's do that over here. To determine whether it's a perfect square trinomial, look at the ends first. Are these perfect squares? This is a perfect square. It's k squared. This is a perfect square. It's 9 squared. So what I'm doing over here is I'm writing down the square roots of these two things. If they are perfect squares, write down the square root of them underneath. Now the big question is, because this doesn't necessarily make it a perfect square trinomial, the big question is, if I take the square roots of the ends, multiply them together, and then double it, do I get the middle term? So k times 9 is 9k. If I multiply that by 2, I do get 18k. So this is, in fact, a perfect square trinomial. So what you do is you draw one set of parentheses with a squared on the top. This term goes here. This term goes here. And this sign goes right in the middle. And you're done. Now you could check it by actually multiplying k minus 9 times k minus 9. You're going to end up with k squared minus 9k, which is minus 18k. And then negative 9 times negative 9 is a positive 81. You'll get this. So it's k minus 9 squared. Number 5. Let's check the order. The order is fine. Is there a greatest common factor? No, so that's good. Now, is it special? Well, it's a binomial, so the only special binomial would be a difference of squares. So first check to see if both terms are perfect squares. The 81y squared is a perfect square. That's a perfect square. That's 9y. This is a perfect square. It's 7 squared. But it's not a difference of squares. It's a sum of squares. Whenever you have a sum of squares, it's going to be prime. What that means is it's not factorable. It's prime. You can't factor it anymore than what it is right now. If it was a difference of squares, then it would be 9y plus 7 times 9y minus 7. Again, we're looking at the a squared minus b squared factoring out to be a plus ba minus b. But again, in order for that to happen, you have to have a difference of squares, not a sum of squares. So we're done. All we have to say is that it's prime. All right, number 6. This is a difficult one, as most of the number 6s are. The reason why it's seemingly difficult is because it's not just x squared minus 15x plus 56. That would be an easy trinomial. We could do that without even using the box method. The problem is we have x minus 2 squared minus 15 times x minus 2. We have those x minus 2's which seem to throw things all crazy. What if it wasn't x minus 2? What if it was something like k? If I made x minus 2k over here and over here. Let me put that in something you can see. It would then look like this, which is something that we could easily do. Well, who says you can't do that? So what this is called is just temporary substitution. What are we doing? We're going to let k equal x minus 2, just for now. Okay, we're going to keep that in the back of our mind. Just for now, we're going to replace any of the x minus 2's, and we're going to stick a k in there. So what we're going to do is we're going to continue with this now. Now that we let k stand for x minus 2, it's an easy trinomial. It's written in the right order. There's no greatest common factor. The k squared comes from k times k. The signs tell me they're going to be the same sign. They're both going to be negative, so I'm going to put a negative and a negative. So I need to write down the list of factors for 56. So 1 and 56, 2 and 28, 3 doesn't go in, 4 does. 6 also does. No, 6 does not, sorry. 7 would be the last one. 7 and 8. So again, they're all negative. The question is, which one of these adds up to negative 15? It would be these two. So, whoops, I shouldn't have put those k's there. Let me just erase those. A negative 7 and a negative 8. So those are our, that's the combination. Okay, so this is all fine and good, but we're not quite done because this says k minus 7. We're not finding out what x is. So remember, we let k equal x minus 2. So k equals x minus 2. So if k equals x minus 2, we can now replace k with x minus 2. So that's what we're going to do. It's now going to be x minus 2 minus 7 times x minus 2 minus 8. So we have x minus 9 times x minus 10. That's our answer right here. This is it. If you had no idea how to do this, and I'm going to erase these k's up here. If you had no idea to let k equal x minus 2, what you could have done was FOIL x minus 2 out, distribute the negative 15 in, and incorporate the positive 56. And then factor with that. What you would get if you did that out would be x squared minus 19x plus 90. That's what you would get if you squared that, you distributed the negative 15 in, and you added the 56. You would get this. And then you could factor it like we did this, and you would get this here. But using k substitution or u substitution, whatever variable you want to use here, sometimes is much quicker than actually going through and FOILing all that stuff out. Alright, now to the review problems. This is a quadratic in vertex form. Let's identify the vertex. So we have the vertex being at 6, 7. It's the opposite of what we see here, comma, what we see here, because this 7 is not hanging out with the y. Remember, if the number is hanging out next to the variable, it's like he's acting differently with his friends than he would if he was all by himself. So if he's kind of acting phony like this negative 6 over here, he's really positive 6. This 7 out here, he's by himself. He's not hanging out with the y. So he's acting exactly like himself. So they want us to identify the axis of symmetry. Remember, that's an equation of a line. So x equals the x value of the vertex. So x equals 6. Max or min value. The a is positive, so it opens up. That means it's going to be a min value. And that min value is going to be the y-coordinate of the vertex, so 7. The domain is all reals, and the range is going to be the set of all y's such that y is greater than or equal to 7, because it opens up. If it opens up, y is greater than or equal to the y value of the vertex. And all of this is your answer. Number 8, find a quadratic model in standard form. You can use a calculator for that. So let's take that, put it over here. Just drag it over. Okay, now what I'm going to do is I'm going to enter these values in. So stat, edit. They're already cleared out, so that's good. So my L1 is 0, 1, and 2. So 0, 1, 2. L2 is going to be 3, 10, and 19. I'm going to hit stat, calc, 5, and then scroll down to calculate. And it gives us A is 1, B is 6, C is 3. So 1, 6, and 3. 1, 6, 3. So we're going to put this in the standard form because we're dealing with the A, B, and C values. So that's what standard form is. In case you forgot, here it is. So we're just going to substitute these values in. So we have our equation. So plus 6x plus 3. And there's your model. Number 9, rewrite the equation in vertex form. So obviously, we have to find the vertex. To find the vertex when it's in standard form, you do the opposite of b divided by 2a. So we're going to have negative 3 over negative 4, which is 3/4. So that's my x-coordinate of my vertex. So let's plug that in to get my y-coordinate of the vertex. So there's the substitution. Let's square this first. So that's 9/16. 3 times 3/4 is 9/4. The 2 and 16 can cancel. You have an 8 down here. So y equals negative 9/8. Let's make all of these eighths. This becomes 18/8. This becomes 48/8. So we're going to have negative 9 plus 18 is 9. 9 minus 48 is negative 39. So that's my vertex. So identify the vertex, mission accomplished, and the axis of symmetry. So the axis of symmetry is going to be the equation x equals 3/4. And last but not least, explain in words how to factor the trinomial completely. Alright, so the first thing that you would do is determine whether it's in proper order. And it is. The next thing you would do is check to see if there's a greatest common factor. And there is a greatest common factor. So that would be the first thing that you would have to describe. You have to factor out the greatest common factor, which is 3. So in factoring that out, you would end up with this as your trinomial inside. So you factor out the greatest common factor, you end up with that. Then you would go on and describe the factoring of this trinomial. So That trinomial is an easy trinomial. So what we're going to do is we're going to find factors of 24 that have a difference of 2. So the factors of 24 the larger numbers are positive, and I know that because this says that there's different signs. The larger number is positive. So the larger numbers here are positive, the smaller numbers are negative. Which one gives me a positive 2? It would be plus 6 minus 4. So to describe all that, you basically say you have to first factor out the greatest common factor of 3 from the trinomial. Then the resulting trinomial here, you would have to find factors of 24 that have a difference of 2. The larger number of the factors would be positive and the smaller number would be negative. So the factors would necessarily be positive 6 and negative 4. And then you're done. You have a final answer of 3 times the product of x plus 6 times and x minus 4. That's it.